great to be here in Ashland. My presentations are usually around 10 to 13 hours. So, in 2 hours, I'm going to try to kind of crunch like a nutshell of the whole thing. So you're going to have to excuse the presentation in terms of me having to jump across slides and find them and go as I go. But, and you're going to have to take leaps of faith in what I'm saying because I don't have time to give you the details. But I'm going to just run you through a little bit of how things happened in my life that brought me to these conclusions and how the physics that I brought forward may create large changes in our understanding of our relationship to the universe, but as well in our understanding of technology and our relationship to our planet, which is crucial at this time. So I'm excited to be here and to present that to you. This really all started when I was 10 years old or so. Actually, it started when I was 7 with some esoteric experiences that made me believe and that had me interacting with all sorts of dimensions out there. And, so I was kind of a strange child. I didn't fit so well in the educational system. I had the worst time, and I was just getting kicked out. I mean, I'm the only person I know that got kicked out of preschool, and I just wasn't fitting in at all. And and so by the age of 10, I already had moved from one school to the other, and when the teacher went to the blackboard and said, today we're going to have our first lesson in geometry, and we're going to learn about dimensions, I got really excited because I thought, oh my God, this is it. Finally, there's going to be an adult that's going to talk to me about all these other experiences I'm having, right? I was so disappointed. The teacher went to the blackboard and made a little dot. It's like that. And said, this dot represents dimension 0, and it doesn't exist. So already, I knew I was going to fail that class. I was in the back of the room. I was always closest to the door, And the teacher, and I wanted to put my hand up and, start asking questions, but I resisted. But I could see that even the other kids were puzzled, and you probably all went through that lesson, and, it's really a fundamental lesson. And actually, this fundamental concept of dimensions and the axiom that comes from it really kind of maps out all of our current advanced mathematics and our current physics. Most of the physics of today, including quantum theory and relativistic equation, assume flat space and Euclidean space and all this stuff. And, from my first experience with it at the age of 10, I knew there was a problem because I could see the dot on the blackboard. So if it didn't exist, how come I could see it, right? So I already had an issue. Then the teacher stuck a bunch of dots together and made a line and said, that's dimension 1, and it doesn't exist either because it's made out of dots that don't exist. And I was like, okay, well, I'm going to go with this, but I'm seeing that 9. So, and then the teacher put these 4 lines together and made a plane and called it dimension 2 and said that dimension doesn't exist either, it still doesn't have volume, and that's the dimension that your comic strips lives in. And, I could see all the other kids were really disappointed that their comic book didn't exist, and I was getting more and more confused. But the confusion reached a crescendo when he got to the next dimension, because then he put 6 of these non-existing planes together to make a cube, and said that cube in closed space has volume, and that is 3D, and that's the dimension you exist in. And now I just couldn't go with that. I mean, I could go with the rest, but I just couldn't go with the idea that a dot that didn't exist made a line that didn't exist, that made a plane that didn't exist, and all of a sudden you slap 6 non-existing planes together, you don't get to enclose nothing, right? And so what you got at the end of this axiom is, you know, a non-existing cube which generates, you know, non-existence to the 4th, not existence. And so I knew at that moment that there was some fundamental error in our concepts of dimensions. And these concepts of dimensions sneak in everywhere. What I'm saying to you is that the concept of, for instance, a 2D surface is a mental construct of humans. It has absolutely nothing to do with reality. There is nothing in reality that has no volume. You know, if you shrink yourself to the atomic level, you'll still see volume. There's still, you know, dynamic, volumic structure to the vacuum. There is nothing in the universe that we could point at that says that is a Euclidean flat space that has no volume, right? So it's a concept of man that we take and then we apply to the universe. Well, if you do that, at that fundamental level of your physics and your math, most likely what you're going to end up with is going to have some serious deficiencies. And you start to see that in advanced physics where, for instance, when we solve universal size and universal dynamics with Einstein field equation, we just happen to be missing 96 to 98% the mass that's supposed to be out there. Right. So you have an equation that only predicts 4% of what's out there. And the assumption is not that the equation is wrong, is that we're missing stuff, so they just added dark matter and dark energy in there. My assumption is that the equation is wrong. But let's not get too far down with that hole right now. So basically, if you've got, so when I walked out of that class, you know, I managed not to get kicked out of that room that day because I didn't ask questions, but I had this long bus ride back home. It was like an hour and a half, 2-hour bus ride. It was just epic because I kept on getting kicked out of the schools closer to my home. And I said that in a talk once to a physics community, and one of the physicists told me I was furthering my education that way. And it's true because I had all this time to think, and I was in this bus, and I was just, you know, and I had to figure this out. And my goal became during that bus ride, you got to figure out dimensions before you get out of this bus. You know, I didn't want to live another minute without understanding, you know, the dimension we're in. And I didn't know that this issue with dimension had been pointed out by philosophers till time began, you know, that like people had worked on this, you know, for eons and so on. I didn't know all that. I just knew I wanted to solve it. And so the bus kept on getting fuller and fuller with people, and it got hotter and hotter, and I was uncomfortable. So I closed my eyes so I, you know, kind of could escape. And you know, when I closed my eyes, I kind of, in my mind's eye, I thought if I want to figure out dimension, maybe I should like try to visualize larger scales. So I escaped the bus in my mind's eye and rose above the bus. And as I rose up, I saw the bus slowly becoming a dot. And then I rose up further and I saw the Earth becoming a dot. And then I rose up further and I saw the solar system becoming a dot. And then I rose up further and I saw the galaxy becoming a dot. And I had this moment of epiphany, like, maybe it's all dots, and then I just flew back in, and in the galaxy, I found the solar system, found the Earth, found the bus, jumped back in, and then I opened my eyes and I looked at my hand and I closed my eyes again. I said, "What about what's smaller?" So I closed my eyes and with my mind's eye, I went into my hand and into the cells of my hand, and I saw that they were dots, I didn't know necessarily they were called cells at the time, probably. But then I looked inside the cell and I saw that it was made out of billions of little shiny dots. And those were atoms. And I jumped into one of those and I looked down the middle of the atom and I saw that it was a dot there. And, and then I kept on seeing dots. And then I got it. I said, oh, the solution to the problem is that instead of assuming that dimension 0 has no dimensionality, that it has no existence, is the exact contrary, is that the only thing that exists is dots. All there is point particle, like singularities. I didn't know that term at the time, but I assumed that everything was made out of dots. And that the universe had all these dots and it put the dots together and made all sorts of things, but that the fundamental structure of space was a dot, a singularity, a point of infinite density that could be divided to infinity. Wow, I was excited about that. I just was flying from one scale of dot to the other, and I could look at the people in the bus and I could see they were made out of dots that were made out of dots that were made out of smaller dots, and they were all shiny. And when you have a intuition or how do you say a revelation, thank you, you get all excited and you want to tell someone. And most of the time, you tell the person and, it's not always well received. Well, I didn't know who to talk to. I wasn't going to talk to the bus driver or anything. So I ran out of the bus when I got home and got to my place, and I waited for my mom to get back from work. And then when my mom finally came home, I was like, Mom, I've got something figured. I figured out something at school today. And she was like, oh, really? She got really excited because she thought I did good at school for the first time in my life. And I said, Mom, there was this lesson on dimension, and I explained the whole thing. And I said, no, I think that's wrong. I said, I think everything's made out of dots, and you're made out of dots to infinity, Mom, and da-da-da-da. And she looked at me with that look, the look of despair on an Italian mother. That's like a force that you got to be reckoned with. And she said, I don't think that's the answer they're going to want on the exam. And you should stick to the curriculum and try not to, do it. And she said, anyway, she said, I just worked for 8 hours and I don't feel infinite at all. And she had made a point. I mean, I kind of realized, wait a minute, I can't be going around telling people that everything is infinite if, how come things have a finite boundary? I mean, things are finite. Mom is finite. How does this work? I can't have finite and infinite. How does this work? And so I basically didn't say anything to anybody else. And I started to think about it, and really it became a source of inspiration and a research from that moment on. By the age of 11, I was kind of really realizing that the concept of the dot having infinite density was interesting, but I had still no way of describing it. However, I was getting very discouraged with the whole world at that point. I was having a hard time with schools. I was discouraged with the world. I was pretty well suicidal and asked my mom, like, would it bother you much if I jumped out the window? And it was at that time that a young master of meditation came into my life. He was only 14 from East India, and I was 11, and I learned to meditate. And when I did, I realized that there was a whole world that, I could turn my senses inward and kind of connect to. And it was kind of the same concept that there was a dot in the middle of me that, that was the source of my existence that I could connect to. And it was really interesting. And then I start to realize then there must be a relationship between what's going in and what's going out. And the relationship between what's going in and what's going out creates a boundary but I didn't know how to explain it. I didn't realize I was describing fractals. And I didn't realize what it implied in terms of physics. Because, having spiritual and philosophical concepts is all good. But if you don't apply it to advanced physics and mathematics and technology, you still have a problem. You still have pollution. You still have all sorts of problems, water raising, that you may be able to solve if you applied these higher concepts. And this planet is really divided. All the spiritual people saying, we don't need no stinking technology. Usually they tell me that on their cell phone driving their car. And I interact with a lot of physicists. I lecture in universities and stuff. And, the physicist, on the other hand, tells me, we don't need no stinking consciousness, and and that's really a problem if you're gonna be the conscious person writing the equation. If the consciousness is not there, how are you gonna write that equation, dude? So that and so like bringing the two together is a really big issue. But I didn't know all these things. Eventually I realized that through simple mathematical equations, and certainly through simple geometric structure, the dichotomy between infinities and finite system can be resolved. And that is a fundamental problem in current physics, meaning the major issue that we're struggling with in physics at this time is infinities. Infinities creep up in the equations everywhere, and singularity is basically unsolved. So it kind of separates quantum physics from relativistic equation, and there's this whole problem in unifying all the math and all the physics due to that infinite problem, infinity problem. So jumping ahead, because we have a short amount of time, you can see how my seminar takes a long time. I got to describe infinity to you guys. But in simple terms right now, I'm going to prove to you that finite systems and infinite systems are actually together, that they work with each other, that actually you can't have finite system without infinities, you can't have infinities without finite system. Boundary structures are necessary to be able to define space so that you can have infinities, and infinities are fundamental to a boundary structure. So I'll show you right here in a simple way that you are absolutely allowed and should think of infinities inside boundaries. Now, we have a little circle here. Now, this circle could be a sphere in 3D, so, don't get stuck on the 2D thing. But it could be a sphere. And the triangle in the middle is an equilateral triangle, and it could be a tetrahedron in 3D. So it could be a tetrahedron inside a sphere. Now, since everything in the universe has spin angular momentum, everything in the universe is polarized. It has a positive, negative, it has a north and south pole. And so since things are polarized, you can add another reverse triangle to that triangle. Interestingly, right away you get one of the most ancient symbol you find all around the world in most of the cultures. And that, that on Sunday about ancient civilization that I won't have time to do tonight. So this can be continued, that is, you can continue to add triangles. And if you add triangles, you get the same geometry again, but in a smaller scale. So we call that in fractal lingo resolution scale, right? So different resolution. So now you can continue to add further triangles, and now you get the same geometry again at a different scale or at a different resolution. And every time you add a new resolution, you're defining a new boundary. Now you see? So now you have smaller boundaries and smaller boundaries again. You can continue to divide the space. Now, it's only in that one. I didn't do it all around, got lazy. But, you could do that again and again. See, it's dividing right now, but you can't see it. And it's making boundaries. And now I could give that program to my computer and run it and get the computer to zoom in every 5 resolution, for instance, and then keep making triangles and zoom in and keep making triangles and zoom in, and it would continue to do that to infinity, meaning, as long as it's got power and, the chips are running, it would continue to divide space. However, there is never a time that I would exceed that first boundary I have set for myself. Right? I would never exceed that first boundary. That first sphere I define would contain all of the divisions of space from there on. That is profound, really. It really is. It's profound in terms of physics, but that gets more complicated. But as well, it's profound in terms of philosophy. And I think, really, part of the reason why ancient civilization had geometry in their Morses and in their traditions and so on is because they were trying to convey that very concept. That concept that infinities are part of the boundary of your existence. That is, viewed from this perspective, everything can be divided to infinity. Okay? And, if physics communities understood this, first of all, right away, they would alter their accelerators projects. Meaning, currently, we thought, when we discovered the cells, we thought the cells were the smallest thing. And then we discovered the atom, and then we thought, oh my God, that's so small? There's billions of atoms in every cell. That's got to be the smallest thing. And then they discovered the electron, and then they discovered the protons, and then the quarks. Every time they go, oh my God, that's got to be fundamental. That can't be anything smaller, right? And now we're trying to find the Higgs boson. I mean, the accelerator has to get bigger every time, all right? And so now the accelerator, which is pretty well the biggest accelerator we ever be able to build, and that means that we've reached the end of our capacity to go smaller, okay, is the Hadron Collider that's being built in Switzerland. It's miles long. It costs $300 billion. 5 countries had to get together to pay for the bill. And now we're looking for the Hadron, which is like billions of times smaller than an atom. What are we doing? We're dividing the space. I mean, we're dividing space at that point, no doubt. And guess what? You can keep dividing, right? We did the same thing in the other direction. We thought our planet was the biggest thing in the universe. And then we thought we found the solar system. Oh my God. And then we found the galaxy. And then we thought we were the only galaxy. And then we found all these other galaxies, and we found superclusters of galaxies. And then, and then universe. And now we think the universe is the biggest thing. Guess what? That universe could be embedded in a larger one, in a larger one, in a larger one, and so on. So, instead of looking for a fundamental particle or looking for a fundamental universe, maybe we should start looking, and that's what I did at that time, for a fundamental pattern of creation, a fundamental pattern of division that define creation. So, in my day-long seminar, I'll be able to show you scaling mapping that we did with observation and equations we wrote that shows that, dimensions are actually, concentric to each other, but as well that the division of space undergoes very specific relationships to each other that defines the geometry of space, that defines how space divides and what scale gets produced at which level. It's not a random thing. And so that is the key, because if we forget the fundamental particle, if we understand the fundamental division of creation, if we understand the fundamental geometry of creation, now we have the key to some of the most powerful information one can have in the universe. The foundation of creation. Okay? Interestingly, if you look at various traditions, Kabbalistic, Hindu tradition, all these traditions talk about geometry being fundamental to the structure of creation. And if we could decode it, we would have this power. What it means to you right now, though, is that instead of thinking of dimensions as planes overlaying each other and things like that, is that to think of yourself as an infinite potential in every single atom that you're made of, right? Like really to sink that into your being, to really connect with that possibility that within you is the infinite potential of the curvature of space-time. I mean, it's all curved into singularity in each of your atoms. And that you absolutely are justified in a non-spiritual way, in a philosophical way, to call yourself an infinite potential, an infinite being. Just mechanically, just by the fact that you can be divided to infinity. And all of these things are happening in a really, really cool way because they all collaborating. All these little infinities, they all got together, billions of them, and they made you. And they all agreeing, we do that, you do that, And that's an amazing thing, Just to give you an idea of the potential information transfer that you represent. Your little thing, singularity, relative to the universe, you look very, very small, right? But in your DNA, if I took the DNA in your body, right, and I put it end to end, so I take there's about, I can't remember how much, I made the calculation, but it was a while ago, per cell, but there's about 100 trillion cells in the body. And I took the DNA and I stretched it out in each cell, and then I put it end to end and calculate how long that is. You could wrap it around the world 5 million times. 5 million times you can take your DNA that's in you right now and wrap it around the world, okay? That's what's happening in you right now in order for you to be here, to digest your food, to look at me, to, function, so your brain works and all this. And so, and all this DNA, imagine this little piece of information on this side of DNA is going across to this other piece of information of DNA, right? Imagine that you had to transfer this information here to that information there, okay, 5 million times around the world after, so that your toe cells don't start making nose cells and your nose cells don't start making toe cells, because a nose in your shoes wouldn't be very comfortable. That's happening right now so that your system is completely coherent. So, why am I telling you all this? Well, you know, first of all, to realize the miracle of your existence is a good thing. To realize what your potential is a good thing too. But as well, to realize that there's an amazing coordination, there's an amazing pattern, there's a fundamental pattern of creation at play here that makes it possible for this to happen in your life. Meaning, it's not a random thing. It's not the universe going, this works, this doesn't work, this works, this, you know, and trying to put together. You can't do it that way. Even since the Big Bang, which is now estimated about 14 billion years ago, you don't have enough time to get even one human being, forget a human being, even like a grain of grass, right, is too complex. I mean, if you take a shovel of dirt, there's about the same amount of DNA as there is in you in the shovel of dirt because of all the microbial content. So imagine all the DNA there is on the planet. You know, imagine all the organization that goes on. It's an amazing thing. And it can't, as far as I'm concerned, and, you know, I think that there's lots of evidence for it, it can't be done in a random way. There's got to be a fundamental pattern. The problem is when you start talking to like that, is people say, oh my God, he must be a fundamental Christian or something. You know, because people, if they think of organized systems, they right away jump to like, you know, the other alternative is that there's some God up there organizing creation. Okay, that's not what I'm saying. I'm saying that there's fundamental patterns of creation in the vacuum, that the vacuum is not nothing, but that the vacuum is actually highly organized, structured, and polarized. And that's how atoms and structures come together and organize, and the network of information is present in the vacuum that allows all that information to be there so that the universe knows what to do and what works, right? Because it's communicating. Everything is communicating with everything. Now, if that's true, then everything is curved to infinity. What I was saying earlier, I know I'm using physics terms, but can everybody understand where I'm going or how I'm... Okay, so that, like, what I'm saying is that if an atom can be divided and divided and divided and divided into infinity, now you're really not dealing with just an atom, but you're dealing with something that would be more akin to a black hole, right? Because it's got infinite density. It's like a mini black hole. A teeny-weeny mini black hole we call an atom, right? And it just happens that there's all sorts of reasons why that may be true, like one of them being that the electron cloud spin at near the speed of light, so you'd expect that in the vicinity of a black hole. The other one is that the fundamental force that holds the atom together, which is thought to be the strong force, in the case of an atom being a mini black hole, just happens to be gravity. If you change the concept of an atom from what it was to an atom being a mini black hole, all of a sudden your calculation says that what holds the atom together is gravity, not some weird strong force that we invented. So that's, you know, all different. And that changes physics fundamentally. But just sit with this for a minute. You're made of billions and billions of mini, teeny, weeny black holes. All right? And they're constantly, through the electron cloud, right, moving information in and out. They're constantly sending information to the vacuum and sending it back out and sending it back in and sending it back out. And that feedback of creation is what we call reality. When the vacuum expands, we see it. When the vacuum expands, we see it. We see the radiation of it. When it contracts, when the information is going in, we don't. We call it the vacuum. And in terms of physics, we call it gravity. So that, according to my theory. Right. So now you have a whole relationship between the radiative side, the electromagnetic field, and the gravitation component. You have this feedback of information, and feedbacks undergo very specific geometric functions in order to be able to do that. And so that's how I figured out that feedback early, and I started to look for the geometry that would allow that to happen. Because I was looking for that key, man. Because I don't like being stuck to this planet. So I was, we'll just jump ahead here, and actually it's the next slide. So now it's long after these thoughts when I was younger, and I've done a lot of physics by then, and at the time my sponsors and my supporter, I think some of you might know Foster Gamble, and he thought I needed to get out there, and he was really encouraging me and supporting me in going and meeting with the mainstream physicists, and and as well to see how my theories would match up and hold up. And so I go to Georgia Tech, and we're meeting with the head of the Department of Physics there, and other physicists and mathematicians, and they're talking about string theory and all this, and then I presented. And there was a certain amount of irritation with those other guys about me, because I don't necessarily have, I don't have a PhD in physics and so on, and I done a lot of physics, and many of them consider that I should have a PhD in physics, but still, and I'm asking really kind of basic questions all the time, and they're talking string theory, 11 dimensions, and and super strings, and they're way out there, and I'm like, well, what about this? And they're and the students there, you could see they're getting upset too and all this. But at one point, I basically pulled out this book, Gravitation. It's kind of the Bible of relativistic equation. Thorne, Wheeler, and Mesner wrote this book, and it's really kind of used everywhere. And when you're talking about a relativistic equation, this is kind of the reference. And I pull it out, and it's called Gravitation, mostly because you see it's really thick, so if you try to lift it up, you get gravitation, you get the idea right away. And I pulled it out, and I open it to page 719, and basically after a few hundred equations you get to this point, and this tells you the fundamental concepts of our universe right now is some kind of balloon that as an analogy is a balloon with pennies glued to it, and the pennies represents galaxies, and as the balloon gets blown up, the galaxies move away from each other. It's the expansion of the universe, and the elasticity of the universe, and all this is described in Einstein field equations and all this stuff in space-time. And so I open it to that page, and I'm like, okay, so if I understand, well, this is our concept of the universe right now, and they're all looking at me going, oh my God, yes, Nassim, this is what we, and we've got equations and stuff, and I'm like, okay, what I want to know is where in here, where in the equations is it that it says, who's this guy? Because I haven't seen it anywhere. You guys don't even talk about it in your analogy here. and I want to know what's happening with this guy. And they looked at me, and there was a long silence, and I could see there was a little sweat beading on some foreheads, and I was like, well, because and then I thought, oh, maybe they're going to think I'm going to start talking about God, at Georgia Tech. That would be like, oh my God, you can't do that at the physics department in Georgia Tech. I reassured them. I said, because, in order for the balloon to expand, right? So I started to draw the rest of the guy, And so you see, when the balloon expands, right, the lungs in the guy has to contract, right? You can't get, for every action, there's an equal and opposite reaction at, fundamental law of physics, remember that one? And that, and then the room got really silent. And I was basically saying to them, there must be a balance between the expansion and the contraction, between what goes out and what comes in, and the information must be going in a feedback relative to that dynamic. I mean, you can apply that to your life right now. I mean, you are expanding energy right now. You thermodynamically even, you're expanding heat. And you got to eat, you got to put stuff in for that to happen, right? Even in terms of your senses, you expand energy so that your sense works, so that when you touch something, so that you can see something, that you can smell something, you can taste something. And those things are going from the outside in. And those things are going in, and you interpret them, and then based on that interpretation, you act outside. Right? So it's that feedback, that relationship between the out and the in and the out and the in. And actually the separation on this planet is that some people say it's all in and some people say it's all out. Right? The spiritual gurus are saying it's all in, and the scientist gurus are saying it's all out. Right? And what I'm saying is no, it's both. Really, you guys, it's both. It's happening because if it wasn't both, it wouldn't function, right? It can't even get anywhere. It won't. You need that guy blowing that balloon, right? You need to pack information in for information to come out. And that starts to give you an idea of the dynamics of creation, the dynamics of you creating the world. Imagine a fractal universe from finite to, from infinite in all directions. How would you find a center? You can't, right? There's no center because there's infinite amount of boundaries. Every point becomes the center in a fractal, right? So you imagine you are the center of the universe. Now as long as you remember that everybody else is, you're going to be all right. But let's assume that, I'm not even saying that philosophically. I'm saying if there's universe embedded into each other to infinity, there is one universe out there that you're the exact center of. I mean, geometrically. Okay? And that is a very large universe. I mean, and every one of you is part of that. But they're all different centers. However, so first of all, to land that in your consciousness is quite an expensive thought. But when you realize that, is that you're feeding information to the vacuum, and the information is being fed back to you in your experience. And a lot of people in the spiritual world now are starting to talk about creating your reality, right? Drives me nuts, but never mind. It's a good thing. It's a good thing in the correct application. I mean, and I think that's where it fails in many cases, because you are creating your reality. But if for 1 second you forget that the rest of the universe is creating its own reality as well, and that it's a feedback between the outside and the inside, then you got a problem. Okay? I used to say Sedona is the worst place to have a car accident. Because, You'll be, dying on the street in blood, and people will come by and say, why did you create that in your life? And it's like, it's a good way to not have empathy, right? But so I'm saying, it's a feedback, it's a relationship. It's not a one-way thing, it's a two-way thing. So it's like we interpret the field, and the field gives us something, but when, in physics, there's a really good analogy for this, because I added torque and Coriolis forces to Einstein field equation to solve for unified field theory. But when you do that, currently in the fundamental concepts of geometry in typical Minkowski space in Einstein field equation, the triads, like the three vectors of space, right, and the one vector at a time. Let's say you rotate it around a geodesic on the surface of a black hole, for instance. It should come back the same, but if you add torque and Coriolis effect, if the black hole has hair, then it comes back change. Okay? And that's what I believe is going on, is that the universe learns about itself by sending information in, and then seeing the result outside, and then interpreting that, and then sending that back in, and that's what a fractal is. From a deterministic, small, simple equation, you reiter it, you get something completely nonlinear. Incredible amount of complexity from a very simple beginning. And I believe that's how the universe learns, and I believe that's how you learn, by your experiences. And so how you interpret it truly is going to influence how it's going to come back to you. But it's going to come back a little bit changed. Because if it wasn't, the universe would stop. Right there, it would be done. It'd learn everything. You'd get bored so fast, right? If you could create your reality and it came out exactly the way you wanted it, you'd, like within seconds, you'd like, whoop! And then you'd be, what do I do now? Right? So that would be the end of the universe. But if it continuously changed, so you want a red Camaro, you get a blue one. Dang! All right, well, now you're starting to kind of have a feel for blue. Next thing you know, you get in a car accident and you have to repaint it. Now it's purple. Dang! So now you got to get a feel for purple. And so on, and so on, and so on. And so that's like, if you start to see your relationship to the universe in that feedback, and I don't have time tonight, but I can show you the equations that prove that that's how the universe functions. I mean, why? I mean, it's not just a philosophical thing. This is why the sun is radiating. This is why the galaxy is there. This is why the universe is there. That feedback in a toroidal dynamic that creates our reality, and the relationship between the two. So I started to realize as well that that there must be, like, let's go back in time again. And now I'm a teenager. I got kicked out of many other schools, and I'm starting my classes in science, and I think it was chemistry. I was in the first class of science was chemistry, and I did in mathematics, and I got really excited. The first thing I put my hand up, I say, can you tell me what an atom is? So I thought, oh, he's going to have some kind of, good explanation for what the heck is an atom, because I couldn't figure it out. And I was really surprised from the answer. First, the answer was, well, that would be a physics question. And second, this is really not part of our curriculum for this, And anyway, in general, we don't know what an atom exactly is. But he said, there's something we know, and that is that atoms are made of at least 99.9999999% space. And I was mind blown by that answer. It's like, oh my God, it's mostly space. And because it doesn't feel that way, I mean, it feels pretty solid. When you hit your head against a wall, it hurts. All this stuff. So it's like, that's mostly space. And so I started to think about it. And that's when I realized that the vacuum structure must have something to do with it. If I asked you today, let's assume that there's something that connects all things, that makes sure that all things communicate with each other so that we can have this level of complexity today. What would be that thing? How would you, if I asked you to point out what connects all things, the only thing you could come up with, if you thought about it for a while, could take you a few years or a few minutes, would be the vacuum, right? There's vacuum at all levels. There's vacuum is everywhere. The space is everywhere. And so, for me to realize that there's 99.999% vacuum everywhere, and especially in atoms, started to realize that the vacuum might have something to do with this. And I realized that maybe atoms are just like little divisions of the vacuum. Maybe the vacuum is what's really there, and the divisions of the vacuum appears to us as reality. It's a difficult thing when you work in the context of mainstream physics, science, and so on. You can't really alter words too much, because if you do, then they don't know what you're talking about. So like the tendency, for instance, in the public is to think of the vacuum as something that's empty, and really actually, even in the physics world, even like top physicists that I talked to about that, and you talk about the vacuum, and they're visualizing either a chamber that's being evacuated, right, on Earth, or a place with nothing in. The thing is that there's no such thing. There's really not an absolute vacuum anywhere. Even intergalactic space, which is the largest vacuum we know, millions and millions of times more vacuum than anything we can produce in a chamber on Earth. In that case, the molecules are only centimeters apart. See, so that's how dense it is. But when you actually look at quantum theory, the vacuum means something even more dense, more incredible. So I was at that chemistry class, and that teacher told us that the atom was made out of 99.99% space, and that's when I started to examine the concept of the vacuum, and I started to think, and during my seminar I'll show, scaling law that shows that the vacuum actually divides itself, but I started to think maybe what we call reality is just divisions of the vacuum. Right? Actually, the only thing there is the vacuum, and when it divides, then we see it. Right? Like when there's a division, when there's a boundary, when there is an event horizon, right? Then we see the result, and we see the result because there's energy in the vacuum, and when a boundary is generated, there's kind of a dislocation of the vacuum, and when that happens, electromagnetic fields are radiated. And so that becomes apparent to us, because now there's radiation, right? And we call it an atom, we call it a sun, we call it a galaxy, whatever. So I started to think in those terms, scaling space-time, scaling structures of vacuum division. And I started to study, and again, in that big book, Gravitation, I found something very significant. I had figured this out before, but it's a good quote from that book. Although that book is not a quantum physics book, it mentions this in the middle of it. Present-day quantum field theory gets rid by a renormalization process of an energy density in the vacuum that would formerly be infinite if not removed by renormalization. Okay. That's quite the statement, isn't it? Now, what is renormalization? Renormalization is what they tried to do to me at school. Not quite. They didn't succeed, as you can tell. The renormalization is a typical trick that's used in physics to get rid of infinities. Okay, in physics, there's two types of infinities. There's one type of infinity that's a quantity that's infinitely small. So like 0.00000, yeah, 1 is so small that you can discard it, right? You can make like it's not there. It's okay, Those are infinities, they don't mind. Okay? Then there's what's called, very technically, actually, you find that in technical books, nasty infinities. Okay? Nasty infinities are quantities that are infinitely big, right? So that is not an infinity that you can just say, well, make like it's not there, right? Because it's an infinite amount of something. And so you got to deal with it. And in general, if a theory gives a result that says nasty infinity, that says this is an infinite amount of something, the theory is either discarded or renormalized. Okay? Renormalization means that they use some fundamental physical constant, they apply it, and they cut the number. They say it's a finite number. Right? So, what they did is when quantum theory started to analyze the structure of the vacuum at the quantum level, that means at the atomic level, or subatomic particles, they realized that in order for the particles to do what they were doing, to have the energy they have, the vacuum, the equation gives infinite amount of energy. There's got to be infinite amount of vacuum energy for atoms to do what they do. And that was not acceptable. So what happened is that they used the Planck's length. They got rid of the infinity by using the Planck's distance, which is 1.616 multiplied by 10 minus 33. Just happens to be very close to a phi ratio, by the way. That is a mathematical constant that's given for the smallest thing the universe does. Okay, it's billions of times smaller than an atom, even smaller than the Higgs boson. They're looking for it actually with that accelerator. They're trying to get mini black holes, mini white holes to appear. But the Planck's distance is what we assume is the end. The universe goes to that, and then it goes, that's it, that's small enough, I'm not doing anything small. That's it. Okay, now, it might be a fundamental boundary, but that boundary is most likely just that, a boundary. And that's the boundary that we can experience in terms of our capacity to solve the physics at hand. So they used that, and what they did is they used that little concept of a small little Planck's distance, and they took a centimeter cube of space, a centimeter cube of vacuum, and they said, how many of these little Planck's distance would we have to put in that centimeter cube of space to fill it up? And that'll give us a finite number for the energy of the vacuum, for how much energy there is in the vacuum, and we won't have this nasty infinity at the end of our quantum view. Wow. That's one way to go about it. And so they took little Planck's distance and they stacked them up. Right? Now, at the end of the equation, when they calculated how many of these little Planck's distance they had to put in there and what's the density of a centimeter cube of vacuum, the density was still, and it's still to this day, 10 to the 94 grams per centimeter cube. 10 to the 94, that's 10 with 93 zeros on the end, right? Okay? Grams of, energy, per centimeter cube of space. Now, that is a very, very, very large number. That is an extremely large number, and if I was to try to give you an example, an idea of what that is, if I took all the stars we see in the universe with the Hubble, okay, all the way back almost to the Big Bang, and like all the stars, like there's billions of stars in each galaxy, there's billions of galaxies, and you stuck them all into a centimeter cube of space, you still wouldn't achieve 10 to the 94 grams per centimeter cube. You still wouldn't have the vacuum density. You imagine, I mean, you need a large trash compactor, you know, and put all the stars in there. Imagine how dense that would be. I mean, like, well, that wouldn't even be the vacuum. So, and do we know that our equations are completely out of line? That, like, this is just like some mathematical error we did? We do. Actually, there's experiments that have proved the density of the vacuum. That is, the Casimir effect has been done in laboratories, and over and over and over. They can put two plates close enough together so that some of the long wavelengths of the vacuum energy cannot get in between the plates. And since they're on the outside of the plates, they create a pressure that pushes the plate together. Those equations were calculated by Casimir in 1947, I believe. And, you know, but at the time there was no way to put two plates that close together without electrostatic problems and all this stuff. And so it wasn't done until the 90s, I believe. And then it was repeated and repeated. And now they're able to even have little teeny weeny, you know, balance scales that they put a plate on one side and it pushes the scale down. And so it's exactly the pressure that was calculated by Casimir in 1947. So you know the equation is correct. So that is telling you that it's really there. I mean, the vacuum has that density, and you're swimming in it. You know, you are like fish in the vacuum structure. You are like, you know, operating in it, and most likely, according to my theories, the vacuum is the fundamental structure under which you came to existence. You came right out of it. And it's a fractal structure of information moving through. I mean, one of the most obvious thing when people ask me, well, you know, why do you think the universe is fractal? Well, you can see fractal structures everywhere in nature, how nature evolves. But one of the most obvious thing is that people come out of other people. That is just an amazing thing, okay? That is good evidence for the fractal nature of the vacuum emerging literally out of other people. And this, you know, and I had pictures of my grandma, or my grandma and her grandma and my mom on the same picture, right? And I could see the fractal division of space, like, I mean, this is, and so this structure is, and so I started to think at that time that the vacuum may be the fundamental dynamics of the division of creation. And that from that vacuum dynamics, you get structures at various levels that self-organizes in ways in which they support each other. So that you get a biosphere that has, you know, fractal divisions creating, you know, vegetation and so on, and then eventually more and more complexity, and you get mammals, and then eventually you get, so that starts to change our understanding from a physics perspective, from a perspective of fundamental physics, even starting to change our perspective of evolution and biology. And I've been collaborating with various biologists throughout the years, one of them being Elizabeth Sahtouris, which is excellent evolutionary biologist, and Michael Hyson on the Big Island, and so on. And it's exciting because really it's the first physics theory that includes biology and evolution. And, you know, that could unify not only the four fields of physics, which is really important to do, but actually the concepts of biology and the evolutionary structures of biology, but as well even the emergence of consciousness out of the biological structures. And why would I say that? And I'm going to finish on that because I want you guys to have the time to ask questions. And this next section I won't have time to finish if I start it. So, you know, let me give you an example. There's this big raging battle that's going on about was Darwin correct, or is it some God organizing nature? And it's really a moot point, because it's not one, or it's most likely neither of these, but something most likely somewhere in between. And and this concept of the division of space and the structure of the vacuum really starts to give you an idea on how the information transfer produces these dynamics. And one of the problems with evolutionary stories that we hear from, mostly Darwinian views, is that there's no evidence for macro transformation of species. That is, you can find lots of evidence for, a turtle coming to the land and developing claws so that they can dig in the sand and dig in the dirt and get food and all this. But there's no evidence whatsoever for a turtle coming onto the land and becoming a bird, right? That just doesn't happen. Turtles stay turtles, birds stay birds. And, even with almost 100 years since, at least 100 years since Darwin, the experimental studies have been done in laboratory to cross vegetation together and try to get like a rose to become a tulip, or a tulip to become a rose, and it just doesn't happen. So there's a fundamental problem. We see micro transformation, but we don't see macro transformation. So what I'm saying to you is that those must be more fundamental than just adaptation to the surface. Meaning, there's got to be a fundamental thread of information that produces a turtle, a fundamental thread of information that produces a bird, you see. And where is that information coming from? It has to come out of the vacuum. It has to come out of the fundamental thread that connects all things, that allows all these things to come out so that they come out in coordination with each other and they can cohabitate and everything is in the right place, right? So it's a new view, really a new view on evolution, and certainly a new view in physics. And what it implies in physics, I'll be able to discuss in more details in the day-long seminar, and you will see it on the DVD if you can't come to the day-long seminar. But eventually, it implies that there is a way if we understand the fundamental dynamics of that feedback in space-time, in which structures can be reproduced to tap into that wheel of creation, into that space-time structure, meaning a society that understands the fundamental structure of creation all of a sudden has the means, technologically, to put a little bit of a wheel on it, if you'd like, so that it can tap into that relationship between what expands and what contracts. All of our current technology is based on expansion. Our most advanced concept of technology are putting fuel, tons of fuel in a rocket, in a cylinder, putting a few volunteers on top and lighting up the bottom and hoping they're going to make it, and just, that is, let's say it's the male approach, the brute approach to creation, and certainly to beating gravity, and it's quite dangerous and not very effective. But imagine that we understood better the concept of contraction, of implosion, of generation instead of radiation, right? What I call general active, actually I took that from Walter Russell, general active instead of radioactive. So that if we tapped into the general active vacuum structure, we would have access to energy, in excess of, whatever we could imagine. And we would start to have capacities that may look today as miracles. I mean, the capacity to start, manifesting things right out of the vacuum, and so on. As well, the capacity to change the structure of space-time to create gravitational fields and so on. So that's one thing. But as well, a society that understands these principles start to understand the thread of their relationship to the universe all the way back to their origin, all the way back through the fractal nature of space. You start to connect with the fundamental power of your existence, and beings that reach that level have very high level of capacity to move information through, meaning it's like if the universe is truly a feedback, it's just like an electrical circuit. An electrical circuit is a kind of feedback. It has a positive lead and a negative lead, and the electrons are moving from negative to positive. And what's in between is a resistor, right? If you take the two leads and you short them, then everything blows up. But in between there's always a resistor. The resistor is you. You are the resistor in that feedback of space-time between the information that's going out and the information that's coming in. And you're changing it every time that it goes through. And your world is adjusting to continue to feed you the information so that you continue to learn. And what changes the amount of information that's going through that is the ohmage of that resistor. Right? And so if you can reduce the resistance, then there's less impedance and the information can move through faster and faster. And you become more aligned and learn faster and grow to understanding higher thoughts of relationship with the universe than thoughts of separation and competition. Similar event happened on our planet millions of years ago. Our planet almost went to extinction millions of years ago, where microbes were producing too much pollutants at the time. That was oxygen for them. And they were all dying. And they were in competition mode. And they went almost to extinction until they figured out that they better collaborate, otherwise they were going to all die. And they started to collaborate, and they produced, I'm giving you this in a nutshell, really, but they produced a multicellular system that started to breed the oxygen, right? And they beat it, and then eventually all this complexity of our biosphere emerged from it. And that came from a change from competition to collaboration. That's all that was needed. And I believe that now the fractal analogy is that we are a bunch of microbe at the next fractal level, right? And we're learning that very same lesson. And we got to get it real quick. Because we're at that point of high stress in our capacity to survive. So, and I believe that learning the fundamental structure of the vacuum, how it applies to physics and technology, and how it applies to consciousness is fundamental to really realizing who we are and our relationship to the universe. And by doing so, realizing our commonality, that we all have that singularity within ourselves, that we all come from the same center. I tell people, we live on a planet, right? It's round. Huh? All of our heads are diverging, right? We're all individual. All our heads are diverging. But all of our feet are converging to the same point that connects us all. That same gravitational field, that same singularity. I mean it philosophically and literally. And that understanding that we are all on the same boat and that we better collaborate, I think is going to clobber us in the next few years. I believe very quickly. And it's going to allow really new level of physics and new level of technology to emerge. So, thank you very much. And if you can, come to the seminar on Sunday. I think there's sign-up sheets in the back. And is there questions? The only thing, the question is, I'm saying the only thing that makes sense is that energy is infinite. Yes. Okay, but yes qualified, meaning that there is an infinite amount of energy, I believe, because there is infinite amount of possibility of division. And so that would produce infinite density and singularity and an infinite amount of energy. But the energy that's available is the energy in which that you're dealing with in the context of a scale, in the fractal structure of space, right? But even in the context of a scale, if we could tap into 0.00 something % of the energy of the vacuum at our scale, we would still be dealing with much more energy that we could ever use. So it's very interesting.
My question is, how do you envision one would access these structures? Just like you need an accelerator to start looking at smaller and smaller particles, do you have a vision of, I mean, what would that look like in your mind?
Right. Huh. Okay. You know, during the day-long seminar, I'll be able to answer that better.
Well, I'll be there.
Okay, good. But in general, first of all, I think that is the main thing is, and what I'm trying to convey here, is that it's important for the individuals to connect with that energy in themselves. You know, that you are one of those things that's tapping into the vacuum energy, because if you weren't, you wouldn't be here. Like, I give you an example. Every atom you're made of is spinning continuously at near the speed of light. I mean, the electron anyway. And you're not pumping them, you're not doing anything. They're doing their thing, right? So the concept, even the concept that you die is not quite correct, because every atom that you're made of is always going to be there, right? You're shedding atoms and picking up others on the way, right? And then when you're done, they're all going to go back to a different scale in the structure geometry of space. You see? All the information is still present. So
Are you saying that it's an internal thing?
there is,
How you're going to...
that's definitely the first step.
It's an inward thing.
Yeah, it's an
not
inward.
through a machine.
Well, then when you've got this figured, which some masters of meditation figured out a long time ago, that there's a point of infinite density, they called it the God point, or they call it the Bindu point, or they call it, you know, there's also the kingdom of heaven is within the whole thing. Right. When you got that figure, then it's a good thing if you can apply that in your external world. And actually, you could start to conceptualize devices that reproduce that, so that you would have access in your external world to energy or space-time warping or space travel, or, you know.
Any kind of concept what that device would look like?
Yeah.
Could you just kind of tell me quickly?
I was trying to avoid that whole thing. Yeah, I think that what that device looked like is actually described in many ancient texts by many ancient civilizations. I actually think that the device was present on our planet thousands and thousands of years before written history, that it was given to us, and that is extremely powerful. And it most likely looks like a sphere that has a very high energy radiant level and is very bright. And in ancient tradition, it was either called the Black Sun, okay, by the Sumerians, or the Black Stone, or there's many, many different references to it. One of them was the Disk of Mu by the South American tradition.
What?
The Disk of Mu.
M-U-U?
Mu. In many different cultures, it's described in the Kabbalistic tradition and so on.
How big,
So
how big is it?
it's very small.
It's very small.
Yep.
Like smaller than this? mean, like-
there's different scales of it. Depends what you want to do with it. So let's say you wanted to power a ship the size of the Earth.
Yeah.
You could probably make one that's the size of a basketball and do the job.
Okay, well,
You're basically building a singularity in a can, a little black hole.
I'm trying to keep the mic.
Right.
You probably already answered it, but if you're challenging dark energy and dark matter, and that's their new theory for the expansion of the universe, what are you putting in place of it for what the evidence they have for the expansion of the universe? That's
Right. Okay, so well, that's a very complex question, but basically what happened is that Einstein, threw in a constant in to get a static universe. And then Hubble found that the universe was expanded. So they took the constant out, right? This is, as far as I'm concerned, that's not appropriate physics, but anyway. And then what they found is that the universe is accelerating as it expands, right? It actually violates, Newtonian second thermodynamics law. And it's accelerating, so instead they added the constants back, and they added enough energy to make it do that. So basically, you know what I'm saying? And so what I'm proposing in my torque paper, I published a new solution to Einstein field equation that includes torque and Coriolis forces in space-time. Currently, the current concept is that our universe is not rotating. Okay, that's one of the fundamental problems. Imagine, everything is rotating, but our universe is not. Right. Well, in this view, the universe is rotating, and space-time applies torque and Coriolis forces on the system, meaning Einstein said that gravity is the result of space-time curving, right? To create gravity, like an object is attracted to another one because of the curve of space-time. What I said in that paper, really, is that space-time curves and curl, spins. And that's the missing energy. So imagine that you are analyzing the wheel of a car that goes from point A to, on top of the hill there, point B. Okay? And you're trying to figure out how it got there, and you analyze all the energy in the tire, all the energy in the rim, all the energy in the axis and the bearings and all this stuff. And then when you finish with your calculation, you're still missing 90-some% the energy you need for that to happen. Well, that's because you forgot to include the torque produced by the V8 engine that turns that wheel. Right? If you don't include the torque, if you don't include the Coriolis forces, if you don't include the engine that runs all that, you're going to be missing the large part of the energy you need to make that happen. That's what I'm saying. It's like they lost the Newtonian mechanical function of space-time along the way, and that's what created the error in the mathematics. It's not something out there that we can't see that makes up the rest of the energy.
Hey. Well, back here. Wonderful thing, when I was in school, they told me 0.999 with the line over the top equals 1. That's when I went out of the box. Wouldn't it be, I kind of find it funny with super colliders, they're trying to create, mini black holes and white holes now. Wouldn't it be, isn't that already happening? Wouldn't it be a lot harder to try and prevent them? But you touched on what I wanted to ask, which is that they have discovered that the universe is expanding at an accelerated rate. Is that not at some point going to define an outer sphere for the universe where everything reaches light speed?
Yes, that's a good question. That's assuming an open universe. They assume a closed universe. So, but what it's a very good question. Let's go back on that question and say, okay, you're saying, I am, that the universes are fractal in nature and that everything is embedded in each other. Okay, well that means that the Earth is spinning around the Sun at a certain speed, the Sun is spinning around the galaxy at a certain speed, which is, I think, I can't remember. And then the galaxy is moving through the cluster, and then the cluster is moving through the universe. If you add those speeds, right? And there's a universe within a universe within a universe. That means that eventually you reach the speed of light for everything. See what I'm saying? So yeah, I am saying that. I am saying that everything is moving at the speed of light, and that's why there is that special relativity thing in which light appeared to move at a constant speed in all directions, okay, from a point of observation, right? It's because that we are actually, you are right now moving at the speed of light. I'll give you an example. So then you're going to say, well, what the heck is movement then? What are you talking about, right? Well, I'll give you the example why we're confused about this. Because we think movement exists, and it doesn't. If everything is embedded in each other, movement doesn't exist. All you got is fluctuations. So you look at your hand and you say, my hand leaves point A and goes here, point B, right? And it's got linear motion from here to there. But if you actually look carefully with the quantum eye and you went in there in the small particles, actually your hand didn't do any of that. In fact, your hand deconstructed itself and reconstructed itself and deconstructed itself and reconstructed itself. And it's happening so fast that you can't tell. And your intent is making it reconstruct in the vacuum at the right place. Because you're moving billions of atoms, right? Billions of atoms. There was researchers, you know, there was researchers that were talking to me about studies that were made about measuring intent. I'm like, looking at them going, what's this? I'm moving billions of atoms with my intent. You think that's cool? You know, so like, what, you know, that's, you know, let's get beyond that and like realize like that's happening, and movement is just a concept. It's like a movie, right? In a movie, you only see, you don't know if you don't have the movie stop that there's frames, no frame, frame, no frame, no frame, no frame, right? But it looks continuous to you, and you would think that's movement, right? But there's no such thing. There's just construction, deconstruction, construction, deconstruction, quantum leaping everything across space-time structure.
Yeah. Oh, she wants me to stand up. Okay. Yeah, I'm glad you brought up that point, because that gives us a whole new perspective, the mind that I share with you, on teleportation. We are teleporting all the time.
All the time.
So why not extrapolate that up into greater teleportation?
Right.
Going back to the beginning of your talk, the thing that started you on this with the points, the lines, et cetera, I think what Edwin Abbott and Rudy Rucker and things like Flatland and the Fourth Dimension, excuse me, what they are is they are encouraging us to think differently, to go way out of the box, to expand our way of looking at it. And there are things, a couple of my favorite things are Mobius strips.
Right.
Klein bottles,
Right.
A tesseract. I have a tesseract on my wall. And what I found out is that instead of just playing with them, if you look into them, if you make yourself small enough to walk the edge or the surface, the single edge or single surface of a Mobius strip or a Klein bottle, or if you look at the tesseract until all sorts of three-dimensional rooms and stars and figures start coming out in it, you have a wonderful series of tools are all around.
Right.
Yeah.
There's evidence of that infinite loop of creation everywhere. And that's a good point. And to like observe it and to realize it. To realize it. I mean, what I was saying on movement, for instance, to realize that. You know, dancers and so on. To realize like the miracle of you doing this. I mean, whoa. You know, it's an amazing thing. Because everything is spinning everywhere, and you're embedded in it, and you're moving at incredible speeds. And so, you know, you're actually ultimately absolutely still in every moment. And each of these moments are piled up so that you think that there is a linear function to it.
Okay.
And that has implication to time as well, and the concept of linear time. Go ahead.
Yes. So you're saying that we are the resistor between the energy information that goes within and goes without this
Yes.
feedback loop.
Yeah.
So What I'm asking you is to address the issue of consciousness.
Yes.
And will and free will within this context, because you're saying we add something to it. We can add to it.
We change it.
We change it. We can modify it.
Right.
So
We always do. We always modify it because as soon as you experience it, you modify it.
So, I know this is a big question, but what is this consciousness that we have that modifies? What's the difference between me, you, who can modify this versus some other being
Right.
that cannot modify it, or modify it partially, or modify it in a different way? What's the difference?
The difference is the ohmage.
That's
Okay,
right.
the amount of
Okay.
resistance and the amount of information that's moving through. Okay,
Oh.
so you're saying I want you to address consciousness, but okay, what is consciousness in this view? In this view, consciousness is the information loop moving through, right? In order to be self-aware, you have to have feedback. See, consciousness is a feedback between the external world and the internal world. And so that's fundamental to all things. So then all things are conscious. All things are feeding information to the vacuum, and the vacuum is feeding it back. Okay? The amount that you're able to feed into the system is related directly to your amount of resistance and how much information can come in. Right? And so that is what makes the difference between you and me, or the other person, or the other person, or the other person. But if you're asking, why am I not, if it's all the same, why don't we all look the same? Then my answer is because we all have a different angle of perspective on everything. So if you're the center of the universe, and I'm the center of the universe, you're the center of the universe from your perspective, I'm the center of the universe from my perspective, this is the center of the universe from its perspective, you're looking at this and I'm looking at this, I'm always going to interpret this differently than you. Just a little teeny weeny bit, and that'll make me a little different. And all these little differences eventually add up to you looking the way you look and me looking the way I look. And that makes us think we're different. But basically, it's just because we all have a different point of perspective on all things.
So is that, from your point of view, from this vantage point of view, is that what we call free will?
Okay, free will means, okay, in this point of view, just the fact that you have a different perspective on things, that you always will, because I'll never observe it from your center and you'll never observe it from my center, is only true as long as we don't move scales. Okay? If we move scales, for instance, if all of a sudden we both became the center of the earth, right? Now we would have the same perspective. Okay? That is a crossing of the event horizon. Okay? Now, so that's one thing. So I would say to you, in technical terms, that free will is only a local phenomenon. Only a local phenomenon. That is, locally, you have free will. That is, you can interpret things the way you want them. But ultimately, there's larger scales that are doing the same. And you're subject to those scales. And so, if you get out of line too far, those scales will make sure that you go back in line. And so you always have a fail-safe system in the universe, right? So that things can always go towards coherency, and no one thing can all of a sudden destroy everything. You see? Because after, let's say you believe in reincarnation. You shoot your foot, okay, it hurts, kills you, whatever. All right, then you come back, you shoot your foot again. Dang, did it again. All right, come back. Eventually, you'll get the idea that shooting your foot is not the best way to go about it, right? So the universe will always bring you to further and further coherency. And actually, I believe you even see that in our equations. It doesn't matter how whacked out our physics get and how many dimensions we have to add. we can't even get out of the truth, meaning it's there, it might not be understood, it might not be complete, but it's always bringing us in that direction. So there's a higher scale of coherency, and then there's the individual, on the local level, free will.
Very clear, thank you.
Thank you.
I just have a quick.
I think we got to go to the mic, I think, because...
When you said the word
Well, actually-
homage, are you saying homage, meaning piety, reverence? Is that what you're saying?
No, I was making a play on word. Okay, Om is the Brahma Om from the Hindus.
Yeah.
That represents a moment of like high alignment, and Ohms in circuitry is a resistor. Is the amount is the quantity of resistance of a resistor.
Okay, I got it. Thank you.
Hi.
Okay, let's make that our last question because.
She's been waiting for a long time.
Oh, okay, go ahead.
Well, first of all, I have to acknowledge there's an element of hypocrisy because, I own a cell phone and a laptop, but my question is about the need for a device.
Right.
Because, ultimately, that's not your ultimate goal with all of this. You've done a brilliant job of explaining to the Western mind what 5,000 years or more of Hindu gurus have been telling us all along.
Right.
So isn't the point
Thank
to
you.
take it within and learn to then radiate it out, but from within? What is the purpose of the device? Because then doesn't that become a tool for power and corruption?
Right.
Does that make sense? Does the question make sense?
Absolutely.
Okay.
You got to remember that like power and corruption and all these things, they're just tools for the learning. Huh? And so, when you learn to walk, you fall and hurt yourself and, learn better and, you should
So the device would just be a crutch then?
No, I wasn't saying that.
Okay.
What I'm saying is, and this is a very fundamental, I started the lecture with this, it's a very fundamental problem. Like I was saying, spiritual people say we don't need no technology, and, physicists say we don't need no consciousness. I understand what you're saying to me is that I've got this image of purity. And in this image of purity, there is no device involved. Okay, that like I'm all powerful. I can do whatever I want. The problem is that in that vision, first of all, which was brought into your mind and based on religious beliefs, the concept, the fundamental concept is that there's a division between your consciousness and atomic structure. That the external atomic world is not part of your higher potential. And what I'm saying to you is that if you eliminate that, you're missing half the feedback. That is, and so that's an esoteric response to your question. And I know you might say, well, you're not really answering what I'm saying. But I want to give you another example. It doesn't matter how many gurus on the planet are able to reach nirvana.
Or manifest gems in the palm of their hand?
Whatever.
Okay.
It's irrelevant because changes on the planet are occurring much faster than all of us becoming these gurus. Okay? And there's great challenge in being able to survive. So at this point, any, non-application of these higher thoughts will only result on all the gurus and the rest of the people not making it. Right? So that, I assure you, and I'll give you another example, because it's so important. You sit and meditate and you go and visit Alpha Centaurus, okay? Let's say. Or you go and orbit Jupiter in your consciousness, okay? That's great. But I assure you that if I landed a craft in your backyard, opened the door, took you on, and brought you to Jupiter, or brought you to Alpha Centaurus, or brought you to the other side of the galaxy, your level of consciousness would go through leaps and bounds. Okay? The level of consciousness of a civilization is always attached to their capacity to reach new fractal scale of relationship to their world, new understanding, new perspectives, right? All the astronauts that went to space that saw the Earth from a different perspective came back changed. You know, when we started to be able to travel around the world, we came back changed. When we were just rocks, and then there was a little water, right? It was just minerals, and then there was a little water, and then the minerals got with the water, and eventually the rocks started to be able to move. That's you and me, right? And as we were able to move, we learned more, and our consciousness grew. So what I'm saying to you is that it's all the same. The device is you, you are the device. It's all the same. And the feedback between the external world and the internal world is crucial. One is just as important than the other, and any one of them that's not present is an imbalance in the consciousness. If you were to tell me this in the context of living in a cave without clothes, without anything, without showers, without anything, and you were able to have that level of consciousness, right? Then I would say to you, I'm wrong. Okay? But the fact is that the reason why you're even able to have a level of consciousness that allows you to have the time to have these spiritual thoughts and everything else is because there's a level of technology that supports that.
I totally agree.
Yeah. So
But isn't ultimately... I'll leave it
ultimately,
there.
you never need technology, and ultimately, technology never needs you. Okay? However, if there was a moment in the universe that this would happen, it would be the end of the universe because nobody would be learning anymore. So the two are always linked.
Thank you.
Okay. Thank you.